Hello everyone. In this video, we are going to talk about interrupts. So what is an interrupt? Let us take an example to understand it. Suppose a teacher is teaching in a class and a student has a doubt. A student generally raises his hand, which sends a signal to the teacher to stop from teaching. The teacher then addresses and resolves the question and then again start teaching. This particular situation can be called as interrupt driven situation. In a computer also, interrupts can be used to perform higher priority tasks. So let us learn interrupts in computers in detail. Let us take another example. Suppose you are sitting in a chair at the home. How do you come to know when someone wants to talk to you on the phone? One way is you check the phone every time to see whether somebody has called or not. The second way is to wait till the phone rings and then answer it. The first situation or scenario is called as polling, whereas the second situation is called as interrupt driven. In the first situation, if we consider a computer, the computer has to check the status registers until a particular state exists. But what happens if something occurs at other devices and the processor is busy waiting? In the second scenario, the devices can send signal to the CPU when the data arrives, and in return of that, the CPU responds by interrupting the current processing and performing the particular task. This is general interrupt flow. Whenever the interrupt occurs, the CPU completes the current instruction, saves the current state to the status registers, then identify the source of the interrupt. Once the source is identified, it will jump to and activate the interrupt service routine. Once the interrupt service routine is completed, it will return to the original program and restore the state. In this flowchart, we are able to see the flow of interrupts. There are two types of interrupts, hardware interrupts and software interrupts. For both the interrupts, same procedure is followed. We are going to check the status registers, save the current state, set the appropriate bit in CCR, load the interrupt vector into the program counter, and execute the interrupt service routine. Interrupts were firstly used in UNIVAC 1103 and 1103A. In UNIVAC, the current instruction was stored in memory and program counter loaded with a fixed address. The other notables are IBM in 1954, which was first to use the interrupt masking, and NBS DISEC, which was first with the IO interrupts. What is the purpose of using interrupts or what are the applications of interrupts? Generally, interrupts are used to modify or to do the additional instruction based on the internal request of the external devices. It also provides a means for suspending the current instructions for more important tasks. So, by using interrupts, we are able to perform higher priority tasks. As earlier said, there are two types of interrupts, hardware and software. Hardware interrupts are also called as resets. The interrupts such as reset, user-defined interrupt, timer operations, CPU operations, monitor failure are performed under hardware interrupts. Under software interrupts, there are illegal instructions and SWI. Interrupts are used for coordinating the I/O operations. Interrupts will notify the CPU that the input is ready or output can be changed. It is also used for timing. Periodic interrupts remind the CPU of the passage of time. By using the interrupts, we are able to perform multitasking, updating the counters, timing during the interactive programs. Interrupts can also notify the error situations. So as you are able to see, many applications are there for interrupts. The practical uses or the examples are the change direction of a motor, auto wiper speed increase or decrease, pressing a pause button on a VCR, HC11 control transmission systems. So all these applications are using interrupts. So what are the different types of interrupts? Basically, the interrupts are categorized into two types, maskable and non-maskable. What is meant by maskable? Maskable means which are ignored or ignorable interrupts. Mostly these interrupts are used. Maskable interrupts are good for using when the computer needs to do something more important. When the interrupt mask is set, interrupts are hidden and therefore are ignored. So these interrupts can be ignored. Non-ignorable interrupts or non-maskable interrupts. These interrupts take the precedence and interrupt any task. The next is interrupt vector table. So whenever an interrupt occurs, the control of the program moves to the interrupt handling routine. How do we know that where the handle routine is stored? This particular address is stored into the interrupt vector table. The address of the ISR is provided by the interrupt vector table. Interrupt vector table has one entry for each type of interrupt. Each entry is indexed by interrupt type and includes a pointer to the handler. This shows the interrupt vector table. You are able to see in this, the first column of this table contains the vector addresses. The second column contains the interrupt source. And the third column contains the CCR mask bit. Maskable interrupts, when the I bit of CCR is set, you are able to see that all these interrupts are set. The I bit is set. These are the lowest priority interrupts, or we can say that these are the maskable interrupts, whereas these are the highest priority interrupts, or we can say that these are unmaskable or non-maskable interrupts. There are 6 non-maskable interrupts. Non-maskable interrupts always interrupt the program execution, whereas there are 15 maskable interrupts. These can be enabled or disabled by the mask bits. Means we are either we can either execute or ignore these maskable interrupts. So when an interrupt occurs, the first thing which the CPU does is stacking order. It finishes the execution of the current instruction, then HC11 pushes it on the stack. HC11 again sets the I bit, looks up vector of highest priority interrupt. It will then execute the interrupt service routine. Once the interrupt service routine is finished, it restores the accumulators and registers. It then returns to the instruction after the one that was interrupted. For controlling the interrupts, the I bit is used. It exists as a bit 4 in the condition code register, in short called as CCR. When I is equal to 1, interrupts will be inhibited and placed as pending. When I is equal to 0, interrupt servicing will be allowed when asked. The I bit is always set while servicing an interrupt. It is set during the reset to allow minimum system initialization. The I bit can also be set by software to prevent the execution of maskable interrupts. SEI, that is set interrupt mask. It can be cleared by software instruction called as CLI, which stands for Clear Interrupt Mask. It is also automatically cleared by the RTI instruction. Which are the maskable interrupts? The maskable interrupts can elevate the priority of one of the maskable interrupts. It uses the bits 0 to 3 of highest priority interrupt register. The default is IRQ. Can be set at any time during the program as long as I bit is set. The maskable interrupt IRQ is the highest priority maskable interrupt. IRQ pin provides an additional external interrupting source. Other additional MCU pins can be used at interrupt inputs. As you are able to see, IRQ is controlled by a pin on the HC11. A low signal will initiate the interrupt sequence. The non-maskable interrupt XIRQ is enabled by the tap instruction by clearing the X bit upon the system initialization. After being cleared, software cannot set the X bit. Thus, XIRQ is non-maskable. Higher priority than any source maskable by the I bit. Both the X and I bits are automatically set by hardware after stacking the CCR. RTI restores X and I bit to pre-interrupt states. There is also non-maskable interrupt SWI. The software instruction thus cannot be interrupted until completed. Uninhibited by global mask bits in the CCR. This is similar to the other interrupts. It sets the I bit upon servicing. Following are the 6 non-maskable interrupts: reset, clock monitor, cop watchdog, illegal opcode, XIRQ, and SWI. The advantages or the disadvantages of using an interrupt is interrupts are more efficient and are also better than polling. By using interrupts, we are able to perform multiple tasks. The disadvantages of using the interrupts is they can occur randomly. and they require additional hardware sometimes. These are some of the references that are used. Thank you for watching.